Carbonic acid.
acid.
Thank you, dear students. So today we are going to start the new chapter. The name of the new chapter is aldehydes, ketones, and carboxylic acid. Let me read very interesting lines about aldehydes, ketones, and carboxylic acids for you, my dear students. That carbonyl compounds are of utmost importance to organic chemistry. They are constituents of fabrics, flavoring reagents, they are constituents of plastics, and they are constituents of drugs. So just by looking at this statement or this sentence, we can understand that these compounds, what we are going to study in this chapter, they are of very important to us and they are very useful to the human being. In this chapter, we should study about the organic compound containing carbon oxygen double bond. So whatever the compound we are going to study in this chapter, they'll have the carbon oxygen double bond called carbonyl groups in the organic chemistry. Now let's move. First, we should look at the aldehydes. So we have a good number of compounds that we are going to study. First, we should know about the aldehydes. Aldehydes, in aldehydes, the carbonyl group is bonded to a carbon and hydrogen. You can see, my dear students, this is the carbonyl group which is bonded to the R. R is known as the alkyl or aryl group. R is your alkyl group. Please remember, R, R is alkyl group or it may be aryl group. So the groups like CH3, groups like C2H5, they are called the alkyl group. Aryl group is C6H5. So this is how, my dear students, we can have the alkyl group and aryl group. So this contain carbon. So the carbonyl carbon is directly bonded to a carbon and a hydrogen. That is how we understand. So in once again in aldehyde, the carbonyl group is bonded to a carbon and a hydrogen. Then next, my dear students, we have ketones. You can see in the structure of the ketone, this is the carbonyl group which is bonded to both the carbon. So in ketones, carbonyl group is bonded to two carbon atoms. Then, my dear students, we are going to study about the carboxylic acid. Even in carboxylic acid, you can see the carbonyl compound. This carbonyl compound is bonded to carbon and to the oxygen of the hydroxyl group. OH group is known as the hydroxyl group. So the same is written in carboxylic acid. The carbonyl group is bonded to a carbon and an oxygen of the hydroxyl moiety or hydroxyl group. There is one exception here in case of the carboxylic acid, that in methanoic acid, or which is also known as the formic acid, my dear students, you can see that the carbonyl group here in formic acid or methanoic acid is not bonded directly to the carbon, but this is the only carboxylic acid where this happens, and we can easily understand it as as an exception in this case. Same way, my dear students, we have an exception for aldehydes even. I think I have not, yes, I have mentioned it, that in aldehydes also we have an exception, that in aldehyde named methanol, or it is also known as the formaldehyde. So in formaldehyde or methanol, you can see that this carbonyl carbon is not bonded to the carbon directly, but it is bonded both the hydrogens, and this is the exception in case of the aldehydes. Now, my dear students, we are going to study few more carbonyl groups. The next one that we are going to study is known as the amide. You can see that this carbonyl group is bonded to one carbon, and in the another group it is bonded to the nitrogen of amine group. So let us read the text, that In amide, carbonyl group is bonded to the carbon and nitrogen of NH2 moiety or amine group. Then we have the another class of compound which are known as the acyl halides. You can see here in the acyl halide we also have the carbonyl group. This carbonyl group is bonded to the carbon. At the same time it is bonded to the halogen. You know, my dear students, in group 17 of periodic table, we study about the halogen. They are mostly the fluorine, chlorine, bromine, iodine. Generally, majorly, this chlorine and bromine are bonded. But even if fluorine and iodine are bonded, we call them the acyl halide. These all are considered as halogen. And in acyl halide, you can see that the carbonyl group is bonded to the carbon and halogen directly. Now we are going to study a few derivatives of oxalic acid, my dear students. So oxalic acids have few derivatives. Let us study about the derivatives of carboxylic acid. I'm sorry, I spoke oxalic acid. I'm really so sorry. The derivatives of the carboxylic acid. The first derivative of the carboxylic acid is ester. You can see this is the part of the carboxylic acid. So when the H of the hydroxyl group which were present into the carboxylic acid, if it is replaced by the alkyl or aryl group, that is R dash, it may be alkyl or aryl group, then we get ester. So hydrogen of carboxylic acid, if it is replaced by alkyl or phenyl group or aryl group, we get an ester. Same way, my dear students, we are going to study about acid anhydride. You can see here the structure of acid anhydride. This is the part that belong to the carboxylic acid. Instead of bonding H here, this H is replaced by R dash CO group. This H is replaced by R dash CO group. So, in if hydrogen in carboxylic acid is replaced by R dash CO group, we get an anhydride, which is also known as acid anhydrides. So, thus, my dear students, aldehydes, ketones, carboxylic acid are widespread in plants and animal kingdom. They play an important role in biochemical processes of life. They add fragrance. Please remember, in most of the fragrances or the body sprays and other sprays which gives us the fragrance, I'm sorry, and they give flavor. They are also used as a flavoring agent to the nature. For example, we have vanillin. We eat vanilla ice cream or we eat the cakes which are vanilla flavor. That comes from the vanilla beans. You might have heard about the salicyl aldehyde that comes from the meadow sweet. We have more well-known sweetening agents or flavoring agents or that we have cinnamaldehyde that comes from the cinnamon. So these are the compounds, they have the pleasure fragrances. You can see their structures, my dear students. This is the vanillin on your screen, which is again having the aldehyde group. Same way you have salicyl aldehyde, which has got the aldehyde group. You can even look into the structure of the cinnamaldehyde, where it also has the aldehyde group. So these aldehydes, what we have seen, they add flavor, they add smell, or they are used as a flavoring agents. They are used in many food products and pharmaceuticals to add flavors. Some of these families are manufactured for used as a solvent. So some of the aldehydes and ketones are used as a solvent. A very good example is acetone. Your acetone is a well-known ketone. The formula for acetone is CS3CSOCS3, which is also known as propanone, which is a very good solvent and it is used as a solvent into the industries. And these families also used for preparing the materials like adhesive, which are like Favicol, which are used to join the things, paints or colors. resins, perfumes, plastics and fabrics. So all the compounds that we are going to study in this chapter are very useful into these particular areas like uh, like solvent, like flavoring agent, into the preparation of adhesives, into the preparation of paints, into the preparation of resins, into the preparation of plastics and fabrics and perfumes and all. So now, my dear students, let us have a look at the nomenclature of the aldehydes and ketone. So the next point, that how do we names to the aldehydes and ketone compounds? Aldehydes and ketones are simplest and most important carbonyl compounds. There are two systems of nomenclature of the aldehyde. We can give name by the two various systems. One system is known as the IUPAC system, which was given by the International Union of Pure and Applied Chemistry. But at the same time, we also use the common names frequently for these aldehydes and ketones. So let's have a look at the common names. Aldehydes and ketones are often called by their common names instead of the IUPAC name. The common name of most of the aldehydes are derived from the common name of corresponding carboxylic acid by replacing the ending "ic" of acid with the aldehyde. So let us study the same. At the same time, the name reflects the Latin or Greek term for the origin or the source of the compound or source of the acid or aldehyde. So common names are generally given from their origins or the source. The location of the substituents in the carbon chain is indicated by the Greek letters alpha, beta, gamma, delta. So how do we locate the different carbons? That is what we can see here. The alpha carbon being one directly bonded or linked to the functional group. Please remember the carbon that is directly bonded to the functional group, that is the aldehyde group or ketone group, is called the alpha carbon. Then the next carbon is called beta, then gamma, and then delta, so on. This is how, my dear students, we understand the position. For example, if we have CHO, which is a group, then we may have various carbons, and these various carbons are called alpha, beta, gamma, delta. This is how we give the name according to the common name system, my dear students. So this is what we study according to the system of common names. Let us again see if we have C double bond O group, then and we must have the carbon at the both the sides. So when we have carbon at the both the side carbon should be given the same name. These both carbons will be called alpha. These both carbons will be called beta. These both carbon will be called gamma, and so on. And the next carbons will be called delta. This is how we provide the nomenclature according to the common names. So now let's look at this. You know, this compound is acetaldehyde because we have acetic acid, CH3COOH. So for two carbon we use this word acetic acid. So this is what it is known as the acetaldehyde. Now if I write the name, my dear students, acetic acid. You can see this ec and acid is being removed and aldehyde, word aldehyde is added. So this is what it is known as the acetaldehyde. So just by replacing the ec, we get acetaldehyde. Same way if we have benzoic acid, so ec acid is being removed and then we added the aldehyde word at the back, and then we have got the benzaldehyde. So this is the way we give the common name. Let us understand the common name system with few more examples. You can see here that this compound has got, this is the functional group. So the first carbon is called alpha, beta and gamma, and this is how the name given as beta bromo, bromine on beta carbon, beta bromo butyraldehyde. So this is how, my dear students, we understand about the beta bromo butyraldehyde. Then next, my dear students, if we look at the system of ketones, we realize that in ketones, my dear students, we give names. Let us give names or common names to some of the ketones. Ketones, the common names of ketones are derived by naming two alkyl or allyl groups bonded to carbonyl group. The location of the substituents are indicated by the Greek letters alpha, alpha dash, beta, beta dash. So if we have same carbon, so this if we call it alpha, we should call it alpha dash. This should be, the next carbon should be called beta dash, and this side it should be called, if we have carbon here, we call it beta. So both the side we cannot give the same, so we use alpha, alpha dash, beta, beta dash for the ketones, and so on. Begin with the carbon atom next to the carbonyl group indicated as alpha, alpha dash. Some ketones have historical common names. The simplest dimethyl ketone is known as acetone. Alkyl phenyl ketones are usually named by adding the name of acyl group as a prefix to the word phenol. So you can see that here we have given the name acetone. You can see here the word phenol is being added. Just, this CH3 group is replaced by the aryl group, and that is why it is known as the acetophenol. Aceto, this aceto is there, and then we have added phenol. Same way, 2, and 3 carbon, so it's a propane. 3 carbon represents propane, and then it is again phenyl group, and this is carbonyl group, so it is propiophenol. This is how, my dear students, we understand the acetophenol, we understand the propiophenol very easily in this case. Now, my dear students, we have few more. This is what it is known as the benzophenol. On both the side of the carbonyl group, we have phenyl group, and it is known as the benzophenol. Now let's look at the IUPAC names. The IUPAC name of open chain aliphatic aldehyde and ketone are derived from the names of the corresponding alkanes by replacing the ending E with al and on respectively. In case of the aldehyde, the longest carbon chain is numbered starting from the carbon of the aldehyde group, while in case of the ketones, the numbering begins from the end near to the carbonyl group. So, my dear students, in aldehyde, we always have this CHO group ended in the ending carbon. So, number 1 we start giving in this manner. But if we have carbonyl group into the ketones, so we will have to start giving the names from the nearby carbon. This carbon of the carbonyl group should get the least number. That is the route we follow while giving numbering. The substituents are prefixed in the alphabetical order. Please remember that we follow the law of the alphabetical order for substituents along with the numerals indicating their position in the carbon chain. The same applies to the cyclic ketones where the carbonyl carbon is numbered 1. Remember, even if we have the cyclic ketones, this carbon which is having double bond should be given number 1. when the aldehyde group is attached to a ring, suffix carbaldehyde is added. Please remember that when we have the CHO group bonded to the any cyclic ring, then the suffix carbaldehyde is generally added to the name after the full name of cycloalkane. So suppose you have this pentane ring and then you have CHO, you are going to call it. See, you are going to use carbaldehyde. So after the name of the cycloalkane, so this is pentane. So you will call it pentane carbaldehyde. So this is how, my dear students, you can understand the method of the IUPAC nomenclature. The same we can understand, or we will understand with the example. The numbering of ring carbon atoms starts from the carbon atom attached to the aldehyde group. A functional group carbon should be given priority. The name of the simplest aromatic aldehyde carrying the aldehyde group is with the benzene ring is benzaldehyde. This benzaldehyde is, however, accepted by the IUPAC system, and even in IUPAC system, it is called benzaldehyde. Other aromatic aldehydes are named according to the according as the substituents of the benzaldehyde. So please remember that other substituted benzaldehydes are given name as if they are benzaldehydes only. Let us understand the various points of nomenclature that we have studied. You can see ethanol because two carbon, so it is ethane, and al is the suffix. You can easily see that the numbering is started from the carbonyl carbon, and then on third and fourth carbon we have bromo group. So it's a 4 bromo 3 methyl. Actually here instead of CH bromo, we should have CH3 group. So it's a 4 bromo 3 methyl heptanol. Now you can look at this. This is, this carbon is given the priority. It's a first carbon, then the second carbon. This is third carbon. On third carbon, we have methyl group. So it is 3 methyl cyclopentanone. You can see it is 3 methyl cyclopentanone. Here we have a method of adding carbaldehyde. So it's a cyclohexane carbaldehyde. We have already seen cyclopentane carbaldehyde. You can see this carbon of carbonyl group is given priority. It's number 1, 2, 3. So on second carbon we have double bond. So 2 in, 1 al and 5 carbons of pent. So it is pent 2 in al, or you can even add 1 here and call it pent 2 in 1 al. Same way, my dear students, we can move forward. You can see here the phenyl group is bonded. This carbon is given the priority and one number is given to this. So it's a 1 phenyl and 3 carbon. So it's a 1 phenyl propanone. Same way, my dear students, you can understand the other examples like, these two carbons have carbonyl group. So one carbon is considered uh, as a lower importance. This is this is aldehyde group. So aldehyde group is given priority, and ketone group is considered as a prefix, as an oxo. So on third carbon we have oxo and total 5 carbon and aldehyde, so we call it pentanol. So this is how we give the name 3-oxopentanol. Let us understand few examples, my dear students. Uh, Here you can see that 2,4-dimethyl pentane 3-on. This carbonyl compound can get number 3 from whatever side we give numbers. So we have chosen the number giving from the right side. So on second carbon we have methyl, on fourth carbon we have methyl. So 2,4-dimethyl, total 5 carbons, so pentane. And on third carbon we have carbonyl group. You can see easily that on third carbon we have carbonyl group, so it's pentane 3-on. Same way, my dear students, we can go for the uh, aromatic compounds. This is 4. You can clearly see this carbon is 1. So 1, 2, 3, 4. 4-nitrobenzene carbaldehyde, or we simply call it 4-nitrobenzaldehyde. Now this is the very important nomenclature. You can see that There are three aldehyde group present in this compound, so they are given the number 1, 2, 3, and to give identical treatment to all these three aldehyde group, they are named as propane 1, 2, 3 tricarbaldehyde. Please remember these names. It is frequently asked into the exam. Note, my dear students, in the next names, the common names are written with the black pen and the IUPAC names are written with the green pen. You can see for this compound, the common name is formaldehyde, the IUPAC name is methanol. For this compound, the common name is acetaldehyde, the IUPAC name is ethanol. For this, my dear students, we have uh, this this structure can be written in this form. So we have three carbon, 1, 2, 3. On second carbon we have methyl group, so it's a 2-methyl propanol because three carbon, but it is also known as the isobutyraldehyde because this group, my dear students, is known as the this group is known, or when we have 4 carbon, so this particular group is known as the isobutyl group, and that is why it is known as isobutyraldehyde. Please learn this name because it may be asked as a common name. You can see this is alpha carbon, this is beta carbon, this is gamma carbon, or 1, 2, 3, and that is why we give the name as 3-methyl cyclohexane carbaldehyde or gamma methyl cyclohexane carbaldehyde. You can look into this compound. This has got OCH3 with it. So if we give numbering 1, 2 and 3, so see I have simplified this for you. So 1 carbon, 2 carbon, 3 carbon. On second carbon we have methoxy group. So it is either alpha methoxy because the carbon next to the functional group is called the alpha carbon. So it is either alpha methoxy propionaldehyde or 2-methoxy propanol. Let us study a few more naming so that we can understand it well. As it has got 5 carbon, it is known as the pentanol. But please remember that pentanol is also known as the valeraldehyde. This is what it is, acrolein, the common name, but the IUPAC name is prop2-enol. You can see this is al or aldehyde group on second carbon double bond. So it's a prop2-enol. Same way, my dear students, when benzene ring has got two carbonyl group bonded to it, it is known as the phthal. So it is phthalaldehyde or benzene 1,2 dicarbaldehyde. You can see that the numbering is given from the benzyl aldehyde group 1, 2, 3. On third we have bromo, so it is meta-bromobenzaldehyde or 3-bromobenzene carbaldehyde, or sometimes only 3-bromobenzaldehyde. In this simple ketone, there are 5 carbons, so it is pentane. On second carbon, we have ketone group, so it's pentane 2-on or methyl, one side methyl, another side normal propyl, so it's methyl normal propyl ketone. You can look into this structure, that this structure can be easily explained or named by giving this structure. We have 1, 2, 3, 4, 5 carbon. On third carbon we have ketone. On second and fourth carbon we have methyl group, so it is 2,4 dimethyl